Hello, my name is Robert Gollehon, and I'm a technical support analyst with the identity management team, focusing primarily on the Oracle Access Manager product. I'd like to welcome you to the Oracle Identity and Access Management Insights session titled Configuring Oracle Access Manager as a SAML Service Provider. This is a 25 to 30 minute presentation that is recommended for anyone who's using the 12c version of Oracle Access Manager. We'll start with a brief introduction to SAML and the service provider roles and OAM supported functionality. We'll then cover a simple use case of configuring OAM as a SAML service provider and how to test an identity provider federation partner. We will describe how to protect OAM resources to use SAML authentication. And finally, we'll provide some resources for SAML implementation and references. SAML stands for Security Assertions Markup Language. It's an authentication protocol used to assert user identities and allow single sign-on across organizations. This may be between different branches of a single organization, such as between a college's primary campus and its satellite campuses, or between entirely separate organizations, such as between corporation and one of their benefits providers or one of their external partners. SAML Service Provider, or referred to as SP functionality, was introduced in OAM 11.121. Prior to OAM 11.121, Oracle had a separate product, Oracle Identity Federation, which was used for federated authentication. There are two common roles for federation: service provider, which we'll be talking about in this presentation, and identity provider, or IDP, which we'll cover in another presentation. OAM is capable of filling both of those roles. The service provider does exactly that. It provides services to end users, usually web services. The identity provider identifies the user identity and asserts it to one or more service providers so that the service provider has an authenticated user to deal with. Generally, but not always in federation, it's expected that there will be a user in the service provider that the authenticated user at the identity provider can be mapped to. So we'll have a local user store on the service provider that we try and map the users to. In OAM, authentication via an external IDP is configured just like any other authentication scheme. So we treat it just like an LDAP authentication or WNA. There's really no difference in that regard as far as protecting resources goes. There are a couple of additional options which we'll talk about, though, that are available when using an external IDP. OAM generally provides support for most standardized SAML functions as laid out in the SAML specification, including bindings, name ID formats, message structure, and flows. OAM allows mapping of users based on name ID value and the SAML assertion attributes. Time here doesn't really permit covering what all these are, unfortunately. So if you're interested, you can go out and read about the SAML specification. There's a good Wikipedia page on it, or there is, of course, the OASIS documentation that fully documents the SAML spec in more detail than you could ever want. Or OAM also supports requesting specific authentication methods from an IDP based on the level of protection of resources in OAM, if the IDP supports various authentication methods. OAM supports IDP-initiated federations where the user logs in at the IDP and is sent to a destination, either specific or a default destination on the service provider. Of course, we also support the normal SP-initiated federation where they access a resource on the SP and redirect it to the IDP. Almost goes without saying, so I didn't list it here. OAM supports federated logout so that when the user initiates the logout on OAM, they can also be logged out on the identity provider side or vice versa. So that when they log out one place, they're logged out every place. OAM provides support for just-in-time user provisioning, where if there is no existing account for the user on OAM to map the related account on IDP2, we can create one on the fly. Optionally, it can be populated with attributes provided from the IDP. There's also full customization of user provisioning. OAM provides the capability to customize SAML message processing to potentially accommodate proprietary or non-standard messaging requirements. It's also possible to configure OAM to perform additional post-authentication login processing, such as requiring additional authentication factors, also known as multi-factor authentication under certain circumstances after the federated login completes. In this section, we'll talk about configuring the SAML-SP functionality in OAM and creating an IDP partner entry. So there are general steps for configuring OAM as a SAML federated service provider. Those are enable the service, provide the OAM SP metadata to the IDP partner, create attribute mappings, which is optional, create an IDP partner, which consists of several sub-steps, loading the IDP metadata or manually configuring the IDP partner, configuring user mapping, selecting an attribute mapping profile, which is optional, creating the authentication scheme and module, which is also technically optional, and configuring single logout, which is optional. To enable the OAM federation service, if it's not already enabled, we need to log into the OAM console and click the configuration button. From the configuration screen, we click the available services button. On the available services screen, we click the enable service button next to identity federation service entry if the identity federation service shows is disabled. On the resulting pop-up, we click enable service to confirm. And when we're returned to the available services screen, we see that the federation service is enabled. You don't have to restart OAM at this point. It should work fine without a restart. Next, we're going to talk about providing the OAM SP metadata and where you can get it. So we want to provide the SP metadata to our federation partner if they can use metadata. If they can't use metadata, it will contain all the information they need to manually configure. There are a couple ways to configure to obtain the metadata. The first is by accessing this page on the OAM managed server, OAM fed/sp/metadata. If this is externally exposed, you can just give the partner the URL and they can come get the metadata themselves. You can save it if you access it from a browser by just right-clicking on the page and saving the content as an XML file. It's worth noting here that OAM includes metadata for all OAM services in its metadata. Occasionally, this is a problem for partners attempting to load the metadata, which is why they might have to manually enter it. But usually, if they support the SAML specification in toto, then this shouldn't be a problem because it's valid. I've collapsed the entries for the other services, the IDP service, the attribute authority and role descriptor services, as well as the signing and encryption certs to show the SP endpoints only. So normally there would be a lot more information on this page. It's there, it's just been collapsed. The locations for the OAM service endpoints is taken from the OAM configuration settings access manager LBR settings page. So that's where the hostname and port and protocol for these URLs come from. The URIs are static and can't be changed. Those have to be what they are. That's where the OAM server listens for the messages for SAML. A given OAM environment can only use a single HTTP endpoint at any given time and a single entity ID. We can also download the federation metadata from the OAM console configuration page, selecting View Federation menu item. On the federation settings page, we can click the Export SAML 2.0 metadata button and follow the dialog to export the SAML metadata to a file that can be provided to our partners. As a side note, we can also customize on this page the provider ID, which is used to populate the entity ID in our metadata, and the signing and encryption keys used by OAM for federation. Note that changing the provider ID only changes the provider ID or entity ID in metadata. It does not change the SAML endpoint URLs. Those are controlled by the Access Manager load balancer settings. In the interest of time, we won't create an attribute profile, and we'll jump straight to creating the identity provider partner. To do this, in the OAM console, we navigate to the Federation screen by clicking the Federation button at the top of the screen. And then we click the Service Provider Management link as we're configuring the OAM Service Provider service. In the SP Management screen, we click on the default Identity Provider tab, so we're already there. We click the Create button, which brings us to the IDP partner creation screen. Here we provide a partner name, which can be anything really. It's just something memorable for us to reference the partner by. I'm going to skip over the protocol selection portion of the service information. We're using SAML 2.0, which is by far the most common selection. It's also possible to select SAML 1.1, which is an older version of SAML that isn't really widely used, or OpenID 2.0, which is another authentication protocol, not to be confused with the more commonly used OpenID Connect, which is a totally different thing. It's a totally different protocol. OpenID 2.0 is not OpenID Connect. Then we need to provide information about the partner, the certificates and endpoints. There are two ways to do this. The first and best way is to click the Load Provider from Metadata, which is fairly self-explanatory. You click the Browse button and just browse to your metadata XML file that you've got from your partner. You can also choose to manually enter the partner data. If you choose to manually enter the partner data, you would need to be provided appropriate information from your partner, and as an absolute minimum, you would need to provide a partner ID, which is also the entity ID if you're looking at metadata. This is usually a URL formatted string, so HTTP or HTTPS : / hostname : port, and possibly some URL. You have to provide the SSO service URL, which is the location authentication request will be sent from OAM to on the partner site. So this could be some URL location on the IDP partner site. And you have to provide at least a PEM formatted file containing the partner's public signing certificate, which is used to validate signatures on messages received from the partner. I won't go through the browse and load of the file, but generally the content of the cert file should look something like this. A begin and end certificate tag with some base64 encoded and gobbledygook in the middle, which is the base64 encoded certificate. That brings us to the completed manually entered partner information, which looks like this. We got the subject from the signing cert, and the validity period of the signing cert, and the other data we entered. But we don't want to use that. We want to load from metadata whenever possible. So we've loaded our metadata, and the partner looks like this, specifying the provider ID, the signing cert subject, and the validity of the signing cert. It doesn't show the URLs, but they were imported successfully, because if they weren't, the import would have failed because those are required. So next we can move on to the user mapping section. So this is the same screen. We've just scrolled down to the user mapping section. If no user identity store is specified in the user mapping, we'll use the default user store configured for OAM. If no user search base again is specified, then we'll use the default search base of the user identity store that will be used. These determine, in conjunction, where we're going to look for matching local accounts in our local LDAP that corresponds to the user specified in the assertions received from this IDP partner. For the vast majority of federation configurations, there must be a local user that the asserted user is mapped to. This isn't always the case. Specifically for federations using a transient name ID format, there may not be a local user, and we map it to essentially a catch-all account. But generally, you're going to want to map the asserted user identity to a specific local user. But we aren't going to talk about transient here because that's a bit of a special case. So I'll specify a user store of OUD store, since that's not my default store. You might guess that that's a Oracle Unified Directory user store. I'm going to leave the search space again blank, so it will just use the user search space that's defined for that user store in the user store configuration. In the mapping section, the first and most common option is to select the mapping the assertion name ID field to an attribute in the local user store. This is the default, and by default that maps to the mail attribute. It pre-populates that for you. However, it's also common to map the assertion name ID to, say, the UID if you're using a standard traditional LDAP, like OUD, OID, something based on the X500 specification, or if you're using AD, you might use SAM account name or something like that. Anyway, I'll be using UID. We can also select map assertion attribute to user ID store attribute. This is similar to the first option, except instead of taking user identity from the name ID field of the assertion, it takes the identity from an attribute provided by the IDP in the assertion. So we must provide the name of the attribute in the assertion that would hold the user's identity. Let's pretend there's an attribute in the assertion called username, and we're going to map that in a local store to, again, our UID field. The third and final option for mapping is using an LDAP query. The query syntax is documented in the OAM admin guide, but the name ID and attributes from the assertion can be used to form compound LDAP attribute queries. For example, we've written a query which will match a user that has a UID that matches the assertion's name ID, fed.nameID value, and mail attribute to the email attribute from the assertion. So it will map the assertion attribute email to the user's LDAP mail attribute. And both of those would have to match in order for the user to be successfully returned. You might do that because OAM requires you to have a unique user return. So if you have duplicate UIDs in your LDAP, you may use the email to further uniquely identify a particular user when the user mapping occurs. I'll revert the mapping back to the map name ID to user ID store attribute, just because that's a more common way to do it. At this point, we will return to the top screen and click Save to save our partner, but there's some additional configuration to do after the partner is saved. So I'll look at that in the next slide. You can do an attribute mapping. That's optional, so I've left the default mapping. Once we save the IDP partner definition, a few new options open up, which we should be able to take advantage of. First, I should mention a couple options which were on the earlier partner screen, but we left as default. Specifically, enable partner, which says that the partner is enabled. If you deselect it, the federations with this IDP partner will fail. And the second is the default identity provider partner, which indicates that the out-of-the-box federation authentication scheme would use this partner for federation. While we could theoretically use the out-of-the-box federation scheme to authenticate, as this is our only and default IDP, I personally think it's a good idea to create a scheme and module specific to the partner, if for no other reason than to make the partner more clear in the policy configuration. After the partner is created, we see a button appears on the partner screen, which will automatically create the authentication module and authentication scheme specifically for the partner, the Create Authentication Scheme and Module button. When we click this button, we get a confirmation that the scheme and module were created, and it reports the names that were created with. These will be the partner name, followed by Federation plugin and Federation scheme, respectively. So we can then use the created SAML IDP Federation scheme here to protect resources, just like you might use LDAP scheme or any other authentication scheme. Another noteworthy thing that appears after the partner is created, if we scroll down to the bottom of the partner screen, is an advanced configuration selection where we can configure global logout or enable or disable it. By default, global logout is enabled, which means OAM will generate a SAML logout request to the IDP when the user explicitly logs out of their OAM session. This logout won't be triggered by session expiry or due to idle timeout, but if the user clicks logout, it will log them out both out of OAM and out of the IDP if that checkbox is enabled. We can also toggle the requested response binding from the IDP. By default, we will want a post binding, but if the checkbox is deselected, we will expect an artifact binding. The majority of implementations use post bindings, so we'll leave this as is, and I won't go into a lot of detail about the bindings because that would take forever. The enable HTTP basic authentication only applies to artifact bindings, and the associated credentials here are used for basic authentication for direct communication from the OAM server to the IDP. Don't worry too much about this here since we're using post binding, which performs all the communication through the user browser. Finally, we can use the authentication request name ID format pull down to select a specific name ID format to be requested in the authentication request generated by OAM to the IDP. The default value is none, which means the IDP can use whatever name ID format it prefers. We won't explicitly request a specific name ID format. So our partner is created and configured. We should probably test it to make sure it works, assuming the IDP is already configured, which thanks to Demo Magic Ours, it's already set up. So we move on to testing an identity provider using the SP test harness in OAM. Well, we could just configure a resource to be protected using the federated authentication screen that we created in the Create Partner screen. It's a good idea to test it outside of the OAM authentication flow to verify from a pure SAML perspective that the partner's working before we introduce a WebGate into the mix, which is a little bit different flow. Before we can test using the SP test harness, we have to enable it if it isn't already done. We do this via WST, so we execute the Oracle Common WST.sh script. This is in a little bit different place for OAM 11G, but I don't worry about that too much. Once in WST, we click connect, provide the connect command to connect to the OAM admin server. We provide the username and password for an admin user, as well as the admin server endpoint. Most OAM Federation WST commands have to be run from the domain runtime context, so we enter a domain runtime command with no parameters that puts us in the right context. Then we can run the configure test SP engine command with a true parameter to enable the SP test harness. Hopefully this returns command was successful. If not, you may have to review your prior commands to make sure they all completed successfully, or check your admin server diagnostic log or log a support ticket. But generally this all pretty much works. So once it's enabled, we don't have to restart. We can access the SP tester by accessing the /OAM fed /user/test SPSSO URI on the OAM managed server. In our case, we only had one IDP and we made it default, so we could leave the part pull down as default, but we click it and select SAML IDP just to be clear. Then we can click the Start SSO button. When we click that, it sends an authentication request message to the IDP partner. And in our case, the IDP partner is samlidp.oracle.com on port 8777. It happens to be another OAM instance, so this is an OAM login. But this could be anything. It could be Okta or ADFS or who knows what. Ping Federate. We don't really care as long as they support the SAML specification. Once we log in at the IDP with our credentials, and again, we don't really particularly care how the user is logged in the IDP. That's not our business. We just care that the IDP tells us who the user was. The IDP will hopefully send an assertion back to OAM, and we get this result page for the SP test harness. This page provides some useful information, like the result, the authentication successful, hopefully. The user identifier, which is the user store the user was mapped to, and the user that matched the user that logged in. It provides the attributes from the assertion, including the standard federation attributes, which are prefaced by fed something. Fed.partner is the partner, and name ID value is the name ID value. And name ID format is the format used for the name ID. And it also provides these unprefaced, raw names, which are attributes in the assertion. So the assertion contains attributes for email and username. Finally, we include the full decoded assertion message, which can be useful to see. It includes the signature and all the stuff that was in the assertion, the validity times, everything. Now we're going to talk about the other way we can test, which is more traditional, by protecting resources to use for SAML authentication. So this may be old hat for a lot of people. This is just creating an authentication scheme and mapping it to a resource. So we go to the OAM console and click the application domain. We search for the application domain. We're going to use OHS Resource WebGate. We go here and click the Authentication Policies tab and create an authentication policy. You could copy one of the existing ones, but why do that? We give it a name, something meaningful, like Federated Authentication Policy. We select an authentication scheme, which is the authentication scheme we created in the IDP partner screen, SAML_IDP Federation scheme. And that's it. We click Apply. So now we've got the authentication scheme created. We need to actually set a resource to use that authentication scheme. So we go back to the Resources tab, click Search. We've got some resources here. We select one. We're going to use CGI bin print env_fed, just a page that dumps out the headers in the HTTP request. We click Edit to edit that resource. We scroll down to the bottom of the screen on the resource screen and change the protection level from excluded to protected. If it was already protected, you might just need to change the authentication policy and maybe the authorization policy, but we definitely want to set the authentication policy to our federated authentication policy. We scroll to the top and click Apply, and we're all done. We're ready to test. So we test by accessing the resource. In our case, it was CGI bin print env_fed. And when we access this, what happens is the WebGate intercepts the request. It goes to the OAM server and figures out it's protected with a federated scheme, and then creates a SAML request to the IDP server. And that's where we end up with samlidp.oracle.com. We provide a username and password there, just like we did for the SP test harness. And basically, it's going through mostly the same flow. It returns us back to the OAM server with an assertion. OAM maps that to a user, creates an OAM session if we successfully find a user, and then sends us back to the requested page with an OAM session, skipping a couple of steps. But basically, that's what's going on. And it displays our page. And we can see here that we've set a couple federation-related responses. We had assertion attributes in our assertion, which I set header responses for name ID value and fed email attribute. We also get the normal standard responses that OAM generates for all protected resources. OAM identity domain, the user store, the user was authenticated to the last re-authentication time. Of course, the OAM_remote_user with the user identity. I have a few resources here. The first is, of course, the OAM admin guide, which contains an entire section of 4 chapters on SAML federation that goes into great detail on implementing SAML and OAM. The SAML specifications can be found on the OASIS website, OASIS being the organization that manages the SAML specification. There are a couple of useful MyOracle support notes. One is how to configure an IDP partner, basically covering the same information. And another useful one for troubleshooting federation issues is how to capture HTTP header traces, which can be very useful in troubleshooting problems when they occur with the federation flow. First of all, to figure out where the problem is actually occurring, whether it's on the SP side or IDP side, and what messages are being sent back and forth, as those are generally captured in HTTP header trace. Lastly, we have some good blog posts on the Oracle blog site, posted by Damien Carew. There are also a few there for IDCS, but there are some useful things like federated authorization and some information on the cryptography associated with the federation product in OAM. Thank you again for tuning in to our session today, titled Using the OAM Service Provider. We look forward to seeing you at our next presentation, and have a good day. Thanks.